Hi, this is version 2 of my playlist number 3 on intermediate to advanced classical mechanics and statistical mechanics. And so when you're like a sophomore in physics, at least in the United States, you should be taking advanced courses you should start courses in quantum mechanics and intermediate to advanced classical mechanics and statistical mechanics. Um, these are like 8.03, I think, and 8.04 at MIT. At Caltech, there's a honors physics sophomore course, Physics 12, A, B, and C, which has that sequence: waves, quantum mechanics, and statistical mechanics. So I probably should have included something on waves in this course, but usually you cover that in first year physics, so I won't include that. So let me get started. First thing is classical mechanics. There are some pure undergraduate books in classical mechanics that cover Lagrangians and Hamiltonians, but the standard book where I first learned it, and it's used in the Caltech Classical Physics Junior Level course, Physics 106, is Classical Mechanics by Goldstein. I actually own, you can see that red book on the top in the picture above my face, from 1951. That's the 1951 edition, but it's now on its third edition. And I recommend this book. Is a very good book. It's not difficult. One of the aims of a book on classical mechanics and classical electromagnetism is to sort of introduce you to new mathematical methods, and sort of, Goldstein does that with rotations and spinors, and a little bit on tensors he does in the book. He covers the Lagrangians and the Hamiltonians. He covers classical fields. He has a fairly good chapter on relativity. The notation is all up to date. He's added chapters on chaos and perturbation theory in classical mechanics. So it's an excellent book, and it's not a difficult book. And I would recommend just using this book rather than an easier undergraduate book. So that's where I would start with classical mechanics. And there is, of course, this is the second edition of classical mechanics. I think the second edition is actually better than the third edition, so might be something to consider. They took some stuff out of the second edition and added some stuff in the third edition. It's your choice. Sometimes the newest edition of a book is not always the best edition. So take a look at both on Amazon, see if you can compare prices, and make your choice. There's also another book which is more mathematical. This is a graduate level book. I've never read it. I've only looked at parts of it. It's a standard book, Mathematical Methods of Classical Mechanics, and it covers everything from a more mathematical approach, and it's definitely graduate level. So I would not try and learn this on the first go with this book, but it is very good on references, proves a lot of theorems. It's a Russian book. It's not that advanced for a Russian book, and it does cover all the basic things, but it just has a little bit more mathematical perspective. So that's another alternative if you already know a lot of classical mechanics. And of course, Landau and Lipschitz Volume 1, they have a very terse book. It's about 150 pages, but what I like about this book is that all the problems are worked out, so you can consider this as a book with solutions. I mean, every chapter, it has problems at the end of every section and every chapter, and complete solutions. So, reading the solutions is not quite the same as working out the problem, but they have some good problems in this book. But it's, like I said, it's 150 pages. Goldstein is like 600 pages, so it's It's a very brief book. Turning now to classical electromagnetism, I used the first edition of this book. It's called Classical Electromagnetic Radiation by Marian, and then it was updated to a third edition. And it was a fairly good book on electromagnetism. It covered a lot of wave properties, optics and wave properties that usually you wouldn't cover in a standard electromagnetic book. And it covered a lot on things like antennas and classical electromagnetic theory, interference, coherence, scalar diffraction theory. And it has a very good chapter on relativistic electrodynamics. So it's considerably easier to read than the standard graduate level book, Jackson. And I recommend this book for another reason, which is that you can get it if you go to the Dover website, and you'll see there's a link here, right here, this link. Let me show it to you. This blue link over here is, it has an authorized PDF of solution book of all the problems in the book. So I know this is not a big thing of mine, but a lot of students, they want to have solutions. And so here you can get the complete solution manual for classical electromagnetic radiation. The standard book on, nope, that's not it, I'm sorry, I'll come back to that. The standard book on undergraduate electrodynamics at the advanced level is Griffith's book, and everybody seems to really like this book. I haven't read it. I think it's basically at the level of Marian, maybe a tiny bit easier than Marian. I'm not really sure. It seems like a fairly good comprehensive standard book, but it doesn't cover the wave aspects as much as Marian does. So if you want to get some kind of optics perspective without reading a whole optics book, this might be a little bit deficient in that area. But it's a standard book, and everybody seems to like Griffiths. So, your choice. But I haven't read it, so I can't really say. The standard graduate book in electromagnetism is Jackson's book. It's now on the third edition. This is a hard book. It's very mathematical. And it's just a difficult book to read. The third edition is in my opinion, I own the second edition. In the third edition, they caved and they went to sort of like MKS and CGS units. They have them intermixed, mainly to get the engineering students. So I kind of like my second edition. There's not much new that they added in the third edition, a little bit, but not a huge amount. But and this is a very mathematical book. It's going to introduce you to all kinds of special functions, Bessel functions, Legendre polynomials, spherical harmonics, spherical vector harmonics. It's a tough read. Oftentimes you have to spend like 6 pages on verifying an equation that he just puts out there and says this leads to this. But in terms of content and 2 excellent chapters on special relativity in Jackson, chapters 11 and 12. And he added a little bit on radiation dampening, but mostly, and virtual quanta, I think. But for the most part, he didn't really add much in the third edition. So I kind of like the second edition. Got a better color as well. You probably can get it cheaper. And it's all CGS units. You don't have to look at those ugly electromagnetic equations in MKS units. Another book, okay, Griffiths I already mentioned. This is a competitor to Jackson that came out a few years ago, Modern Electrodynamics. I've read about a third of it. I really like it. It's modern in the sense that, not in the sense of mathematics. It doesn't have things like all that fancy mathematics with forms and everything like that. It's traditional mathematics, but it's modern in the sense that it's really updated with experiments and new phenomenon and everything. So if you want to see things like negative index of refraction, it's in this book. There's two negative things about this book. It's a 1,000-page book. There's two negative things about this book, and that is that it uses MKS units, and even worse than that, it uses the ICT for relativity, which is, to me, a real faux pas. So it's kind of like it's got a couple of negatives, but it's well written, it's new, and it has a different perspective. I think it's more physical than Jackson and less mathematical. But this is an alternative, and so well worth reading. I kind of enjoy it. Another book that I'm not that familiar with, but that a physics professor of mine was asking about, or he was actually looking for a book to recommend, and this is Classical Electromagnetism in a Nutshell. And I think this is very similar to Zangwill's book. It's, I don't know where I went. This is a little shorter. I think it's about 600 pages, and it seems very similar. And I can't remember what he does with the units. I think he uses a combination as well. Like he switches back and forth. He uses what's appropriate, like when it's a modern physics type, for theoretical physics type of topic, he uses CGS units. When it's an engineering topic, he'll use MKS units. And it's 600 pages long, so it's a little shorter. Finally, well, not finally, but there's also a book by Julian Schwinger. Those of you who know, like Feynman and Schwinger won Nobel Prizes for quantum electrodynamics, and Schwinger is like a mathematical genius. And during the war, whereas Feynman worked at Los Alamos on the atomic bomb, Schwinger worked and developed all of these formulas for radar at the MIT Radiation Laboratory. So he was like the expert in synchrotron radiation and all of these other things. And this book has a lot on special functions, a lot on mathematics of electromagnetism. You know, if it's a Schwinger book, it's not going to be easy. So anyway, another alternative. Oops, sorry. The next final book on electromagnetism is, of course, the Landau-Lifshitz book. This is the best book in the series, I think, The Classical Theory of Fields, Volume 2. It's about 250 pages on electromagnetism, which you might think is a lot of short, which is very short. But actually, this book mostly covers, Volume 2 covers vacuum, electromagnetism in a vacuum for about 300 pages, and then has about 150 pages on relativity, general relativity. But he starts, it's a really interesting read. It's a different perspective on electromagnetism than many other books. And he has derivations that you just don't see in any other books on radiation from charges and various things like that. Like I said, he has 250 pages. There's another book in this series, Volume 9, I think, where he covers electrodynamics in continuous media. So this is sort of like just the vacuum coverage of Maxwell's equations and electromagnetism. And it's an alternative. It's old, but it's a classic. And he also has a couple hundred pages on general relativity. That's also very interesting. So this is a book that's, all of Landau-Lifshitz's books are a little terse, difficult, but they seem to have a little bit different perspective, and you'll learn something that you might not learn in the other books. Okay. Finally, turning to statistical mechanics. This is the easiest book on statistical mechanics. It's sort of like Advanced Freshman, Beginning Sophomore Level, An Introduction to Thermal Physics by Daniel Schroeder, who wrote a book on quantum field theory. So he wrote like one very hard book and sort of one very easy book. The thing about this book is that he's got like a zillion problems in the book. So you can't do all the problems, but he's got like I don't know, it's like hundreds of problems. You're supposed to do only a couple of problems, but he covers like the standard sophomore level statistical mechanics, and and it's a little bit, it's up to date. He's got the condensation. Let's see, Bose-Einstein condensation and Debye theory of solids. So he's got all the usual things, but it's pretty up to date. So in terms of numbers and experiments and various other things, but it's easy. This is like, if you want an easy book on statistical mechanics, you won't find one easier than this. This is the book that was sort of it's based on, which is a little bit harder, not a lot harder. This was used for the Caltech course taught by John Preskill. That's online and still available, and you can find it. And it's got videos and homework assignments and exams and everything. So I recommend it. I probably should have put a link, but you can find it if you Google John Preskill Statistical Physics, Caltech. This book is similar approach to the other one by Schroeder, and it starts with like statistical mechanics and then develops thermodynamics. It's kind of like a boring book, and it's a little bit out of order here and there. It's not the most well organized book, but it's a standard sophomore level book on thermal physics that covers most of what you need to know, even if it's a tiny bit out of date. It's been updated a little bit, but not as much. Another book that's an old book that I highly recommend is called States of Matter by David Goldstein. Goldstein was a Caltech professor who was friends with Feynman, and he was an applied physics professor. And if you remember that series, The Mechanical Universe, on Caltech that was shown on Nova, he was the professor who was always narrating at the beginning for 5 minutes and at the end for 5 minutes. But this is an excellent graduate level book. It covers from the atom on up, as it says in the preface, and it covers everything in statistical mechanics, perfect gases, solids, liquids, and interacting gases. And then he covers superfluidity, superconductivity, magnetism, and critical phenomena. So he covers a lot. It's all at the graduate level, but it's not as it takes a lot from Landau's and Lifshitz' book, but not quite as hard. So I really recommend this book for that reason. The another book on statistical mechanics this one is hard. This is by Feynman. Conceptually, it's not hard, but mathematically, he covers a lot, and you just have to verify a lot of things. It's a classic book. It's your typical Feynman book. He does things in a way that's like different from everybody else, and it's an excellent book to read if you want to learn about liquid helium and superconductivity, and you want to see the Ising model solved, the Onsager solution, and everything. He's got just about everything in there. It was published in 1975, so it's not up to date, but it's still, any book by Feynman is, of course, well worth reading. This one, have your pen and paper on the side because it will be difficult. This is the Landau and Lifshitz book, Volume 5, which is still, they have another volume on statistical physics, but this one is like the basics, and it won't let me look inside here, but it's a typical Landau and Lifshitz book, and well worth reading if you have the time, but not easy. And a lot of statistical mechanics books sort of stole a lot of stuff from this book. So let me see if I can take a look inside in another version. No, can't. Okay. Some specialty books. This is a book I read. I recommend if you're interested in anything with Maxwell's demon, entropy, information, and computing. This is a series of reprints on famous papers, most of them in the 20th century, on Maxwell's demon and various solutions and information and entropy and computing. So it's well worth reading, and it's not a difficult read. Another book that's a little off the beaten path, this was a MOOC. I'll show you the MOOC link in a second, but Statistical Mechanics, Algorithms, and Computations. They do some like very weird things in this book that you just don't see anywhere else. Again, I can't access inside. But I highly recommend looking at this. And it has topics that you won't see anywhere else. It has programs in it. The course, I believe, was in Python, so it's very accessible. And it was very entertaining and fun. It covers, all the Monte Carlo methods, things like hard disk and spheres and order disorder. And so it's just a lot of things in here. It's a short book, about 300 pages, but it has perspectives that you don't see anywhere else. And the course was offered on Coursera. I think it was also offered on edX at one point in time. Maybe not, I don't know, but it was a really good course. I highly recommend this MOOC. This was like one of my top 10 MOOCs of all time. Finally, at Caltech, as part of the candidacy courses, you were required to either pass exams or take a couple of courses. And these courses were taught by various professors, but Kip Thorne and Roger Blandford used to teach various sections of this course, and it took them about 40 years to finally publish the book. I remember in 1980, they would pass out notes and say they will eventually publish the book, and it finally came out like 2017. It's a 1,500-page book. It's very thick and very heavy. I'll show it to you here. How thick it is. You can see it. And they sell them now, each one by the volume, but it's like you could buy the whole thing for about $80, or you could buy 5 volumes at $50 a piece. Which would you prefer? But it covers classical physics from a modern perspective. It uses differential forms, all kinds of modern mathematics and modern techniques. And, it covers, like I said, relativity, fluids, optics, elasticity, and statistical physics. And each part is almost self-contained, not quite. Some of them use other parts. But it's really a masterful presentation if you want to see modern applications of classical physics. They assume you already know your basic classical mechanics, Hamiltonian and Lagrangians, and your classical electrodynamics. So they don't cover that, but they cover all the things that people who do like modern theoretical physics, most students are just in, particle physics or condensed matter physics. They don't learn much about optics or elasticity or plasmas or fluid mechanics. You should know. A good physics students will know a little bit about all these topics, and that's what they teach. So that's all I have to say. I'll come back and do version 2 of the next playlist, I think, is on relativity. Thank you very much for watching. Bye-bye.